Okay, so everybody's, I'm sure, well along in working through the problem set. I guess a couple of things that have been coming up over time are just how I like things formatted, just the nitty-gritty logistics of that, and some occasional issues with downloading the files. So have people in general been able to download the files both for problem 3 and problem 4? Okay, so I'm not seeing too many people nodding no. So, yeah.
I had a problem that didn't seem to come up on Piazza, which was that the file downloaded and I was able to change the name of it, but then the format changed. It was in this, like, it wasn't a normal ASCII character.
Well, then maybe getting the, let's see. So the problem 3 format is it is a zip file, regardless of what the extension what you happen to name it and what the extension happens to be. That doesn't change the underlying format of the file.
It was these like Unicode letters when I opened it up, whereas when I manually downloaded it.
So okay, so you're either manually downloading it or you're automatically downloading it. You're unzipping it in both cases, and then you're looking at it. Is that the procedure?
Yeah, and when I looked at it.
And it varies depending on how you. Okay, so that shouldn't happen. Yeah, so that's something that I need to look at it with you. Okay, but I am at least reassured that it seems like most people are able to get it, to do the download. If you are running into problems, that's something obviously that you can come talk to me about during office hours. And as I said earlier this week, I'm going to be around essentially all afternoon in Park because I'm going to be in the Park to make up for the fact that I wasn't here earlier this week. Okay, so then in terms of the format of the document, basically what I'm expecting, and this will be true for the other problem sets, is that for each problem you have some explanation of what you did, then a chunk of code, then the next explanation for the next thing you did, then another chunk of code illustrating, showing how you solved the problem. I don't want only one and I don't want only the other, for hopefully obvious reasons. For most of the problem sets, excluding this one, that is going to be that you, in either LaTeX or for the non-stat folks, if you like, you can use R Markdown. It's going to be that you have chunks of text and then chunks of code in either LaTeX or R Markdown. You compile that file and that document, and then you create a PDF file or an HTML file, and then you can print that out, and you can send us the underlying. Okay, I guess that's where the issue is. You can print that out and give us that. That will be what you will formally turn in. And then, as I've said, I'd like an electronic copy. And I guess what we need in that case is an electronic copy of the underlying LaTeX file or the underlying R Markdown file, because that's going to be what actually has the code in it that we could run if necessary to check your results. You mean as a separate file? Yeah. Yeah, that's also an option. I'm trying to think on my feet here as to what will work for you guys and what will work for us, and what will be the least logistically a pain for any of us. Yeah, I think that should be fine too. You could either send us the whole document with the code embedded, or you could have pulled the code out and just send us that as a script, either R script or bash script file. For this particular problem set, I'm not formally requiring that you do it in either LaTeX or R Markdown, except for the last problem, obviously. And so if you want to just write this up as just a plain text file and print that out, so make sure it's formatted nicely enough that we can read it, reasonably. And then you can submit that text file, or as Lisa just said, or just submit the chunks of code as the electronic submission to VSpace. So hopefully that wasn't too confusing. And then for problem 5, it's a bit like Jeopardy, right? Like I gave you the answer, and I want you to tell me what the question was, right? So I want to see, as I said in the Piazza note, I want to see your actual LaTeX or R Markdown code, because I already gave you what it should look like after you compiled it. But then, I'll also, go ahead and add on the actual PDF or HTML result that you got as well. Yeah, Jason?
If we write it in text, should we send you the text file or RNW file?
Well, you mean before or after the R processing? Is that the question you're asking? Sort of what level of processing? Before any processing. I don't want to see the. What I want to see is what you basically produced before you did any processing on it. As in the original raw Sweeve or tech file with the R code chunks embedded.
Okay. And so where in particular on the B-space should be uploaded to?
I'm not quite sure yet. I just asked Tessa to set that up. I think there's going to be something on. It's probably just under assignments. There's probably going to be a link that will allow you to then submit.
Is it Dropbox?
Not Dropbox. It's
Not
BSpace. Yeah.
But I mean, on BSpace,
Is there something called the Dropbox?
Yeah.
Yeah, I'm not sure yet. Let me make a note to myself to make sure that we get out sufficient information for you guys to do that submission. And I should know your name, but I've forgotten it. Stephen. Okay.
So then for problems 3 and 4, do you want us to include output in our?
Okay, and that's a very good question. So I guess in general, for all of the problem sets, what I'm looking at in terms of output is I definitely do not want, all of the output, pages and pages of stuff. What I want is a demonstration that it worked and relatively limited output that just, shows a demonstration that it worked. So the way that I would generally kind of do this is I have some text that says what I did and how I solved the problem in a, just in a descriptive sort of way. I then have the code that solves the problem, and then, within that I have results in the sense of, maybe it's the first 3 lines of a long text file or something along those lines, but just something that's indicative or an example of what the result was, but not pages and pages of it. Yes, and you want to
Dustin? Do you want the problem 5 as a standalone or tech file, or do you want it integrated within the rest of the solutions?
In terms of the paper printout, it doesn't really matter because you're just going to staple it together. In terms of the electronic document, I prefer to have everything all together as one file just for our ease in managing it. Yeah. Okay, everyone satisfied? And your name is?
Yeah. So do I have to give you all the results, the printout, or the results of each line code, or just the final answer?
No, I mean, be judicious about it. Just, think of this as I'm your boss, or I'm a colleague who's reading your journal article, and I want to know sort of the big picture and the actual code you used, and then some demonstration that it worked. I don't necessarily need to see, I don't necessarily need to see the results of everything, but think about what you think is a nice presentation of the results. And particularly, the more tricky stuff is the stuff I'd more like to see. The more mundane stuff is the stuff I would less like to see. Okay, other questions? Okay, so let's pick up with the Git demo, do a couple more things with Git, and then we'll launch into Unit 4. So I have this opened up to where I think we left off on Monday. So this is the accompanying PDF. I sort of talked through this. I'm not sure if I actually showed this figure, this idea, as we were talking about adding stuff to the staging area or the index and then committing to the repository, this idea of these 2 steps here, and then that depending on if we get to a certain stage of this, probably a bad choice of words, we can then sort of recover from that and go back to what we, if we added something or made a change that we didn't want. I showed you some ways to go back to where we were as we finished last time. And once you make a commit, then if you made a commit that you didn't like, then the option is, well, you could basically roll back and reset things to a previous commit. I didn't get a chance to look up that syntax exactly when that question came up last time, but I believe it's something like git reset and then basically the name of the commit that you want to roll back to, which is that long string of hexadecimal code that identifies the commit. Okay, so you guys have been sort of playing around with this because I asked you to do a very basic, sort of minimal workflow with Git in for the problem set. Has anything interesting or useful or tricky come up as you've been doing that you'd like to either ask or share with folks? All right, so let's go back and just so this idea of a branch is you might either have two people. Yeah, question.
Sorry, I just have one question.
And are you Sarah?
Sarah, yes. Is there a way to add a function to Git so when we're creating the bash functions? I know we can add the files that we created and then commit that. Is there a way to add a function to it? Or?
The way that I would do that, that's a good question, is I would put your functions in a shell script document, and then you'd be adding that to it. If you want something that's going to persist and will always be available in your terminal, in your shell session in your terminal, without having to source that file, then you would want to put it in your .bashrc or something like that. Yeah, but then I mean that sort of brings up a good point, which is in general, as I said before, with Git, we sort of want to have everything stored in these text files that are going to be basically code files of some sort or another, whether it's LaTeX or R or shell script or whatnot. Yes, and what's your name?
So in terms of
What's your name?
Jimmy.
Jimmy.
Yeah. In terms of the G part, so like I try to download something in this file, and then I only need to record the action of the download, but it shows like there's a new file, but like when I try to commit that, but it doesn't work. I mean, like download the file will be all the workflow.
So I'm not totally sure if I'm following the question, but let me try and answer what I think the question is, and you can tell me if I didn't get it right. Which is, you could do a wget or curl to download the file, and that's part of your shell script. And then if you wanted to have Git sort of be part of your workflow, you could then presumably do a git commit the name of the file, or a git add the name of the file, and then a git commit, and that would get it recorded with Git. That's what was not working. Is that the question?
Pretty much. Like in the action of download, is that will be recorded?
Well, I mean, by the action of the download, do you mean like the stuff that gets printed to the screen?
It's like just the rounded shell and then all that stuff. Like now when I try to commit something, will that kind of work? I mean, like something has changed, or you have rounded shell.
I mean, anything that you do in Git with Git is a shell command, so you can put that into a script and rerun it. And you can always do a commit or an add or anything like that as part of that script. And if you want to save any output that comes to the screen, you can do a redirection with some of the tools that we saw. Yes, so what's your name? Eugenia?
If I separate those in different paragraphs, will it be that it is sort of the whole relevant of the script, or it will just evaluate by paragraph?
So you mean you have different chunks of code? If you do it in R, the stuff in the first chunk should persist into the next one. I'm not totally sure if that will be the case with the bash code or not. Yeah, I'm not sure. Has anybody been playing around with it enough to be able to say yes or no? I mean, you could do a simple test where you create a variable in one and then you try and echo it out in another and see if it exists, and that would be a good way to test it. Okay, so this idea of a branch is that either two people or you yourself want to try out something new and different, but you don't want to ruin what you already have, and so you could create a branch where you try and do this, try out the new stuff that you want to try. So, I'm not in the directory. Oh, sorry, So I redid the stuff that we did yet on Monday in this directory on one of the SCF machines, Arwin. So I should be all set to go here if I could get my copying and pasting to work. That's weird. Oh, okay, that makes sense. Okay, so we're here. We're now going to make a new branch with the get branch command. And now if we do get status, it says, okay, we're on the branch master even though we created this new branch that we're calling experiment. So what we need to do is check out that branch. So that's basically going to shift us over onto the new branch and allow us to work on that new branch. So, oops, don't want to do that. Okay, so it's told us that it switched to that branch. We can do get status, see what it says with get log. Okay. So now I'm going to make a change in this experimental branch. I'm going to add the file, I'm going to commit, and we're going to see that indeed that file got recorded and created in this branch. And I can do a get slog, which was that shortcut that we showed before. And that shows this new commit. Another useful thing here is that didn't really tell us much about really anything about what the different branches were, so we're sort of a little bit in a fog here of not being able to see what's going on with the different branches. So I believe this will work. If we just use get branch without telling it which branch, it'll show us what the current branches are, and it'll show us that we're currently working in the experiment branch. So that's a good thing to be able to do to get a sense of where you are. And if I want to go back to the master branch, I can check out the master. And now if I do ls-l, you'll notice that I no longer see the experiment.txt file because that's in the other branch. And so I just switched, and now I'm looking at the view of this master branch. So I can switch back and forth as much as I like. I can make changes in the master branch. So here I'm going to add a new file in the master branch. And I can see that new file progress.txt is there. Oh, that's interesting. Okay, so it looks like oops, I don't know how that happened. It looks like depending on which branch we're in, we get a different view of what the commits are. So when we were on the experiment branch, it shows us the first commit, this great progress that we made that was from Monday, the changing of the file name that we did on Monday, and then this trying something new, which was the stuff that was done in this new branch when I added the experiment.txt. But if I do get slog in the master branch, I see those first three things are the same as I saw in the experiment branch, but now the most recent commit is this one that I called the main line keeps moving, and we don't see the one about this trying something new. So it looks like the get log, or in this case the slog, is basically telling us about what's been happening in terms of the commits on the particular branch that we're on. Okay, so then often what the workflow will be that you've tried something new and eventually you've gotten it to work, and you want to merge the results of that back into your master workflow. And so ideally, you'll be able to do this merge without actually yourself having to make any changes to integrate the files. That Git will be able to do the merge itself without reconciling any points of contention between the two branches. So often that will be the case. It will either it'll just be able to add any new files in when it's doing the merging, or if each of the branches has made changes to the same file, if those changes have been made on separate lines and they're not incompatible with each other, it'll just it'll merge the different versions of the file together automatically. So we can go ahead and try that we're going to check out the master, and we're going to try and merge the experiment branch back into the master and see what happens. I've lost my cursor. There we go. Okay, so it says something about what it's done. And now we can check to make sure we are where we expect we are. We're on the master, and we can do status. It says things are fine. We can do an ls, and it says, oh, okay, we did. You know, remember, these were the two that were in the master branch. This was the one that was in the experiment branch. You can see it moved it over and made a copy of it here in the master branch. So it has done this merge automatically without having to ask us exactly what do you want me to do. Let's see if this shows us anything interesting. Oh, okay, so this is now useful. So this actually shows us some of this branching in sort of old, this is sort of how computers used to look 20 years ago, right? Everything, all shapes had to be made with characters. So it says, okay, we were here. This was before we did our branching. The main line, this one, the master branch, which has this had the annotation of the main line keeps moving along. We made a change. We had a change to that. We also had this other branch that split off. That had the trying something new annotation to it, and then we merged them back together into the master, and that's where we are. And that's where we are now. And it says, it says that stack is accompanied with this annotation that it did the merge. So you can get an idea of how much branching and recombining goes on. And I think for my purposes of how I've used it and how you're likely to use it in the class, it may not get all that much more complicated than this. If you've got tens or hundreds of people working on a project together, you might see many, many, many different branches and lots of very complicated patterns in terms of things being merged back together. Okay, questions, comments?
Is the experimental branch still exist?
Yeah, it looks like it does still exist. We can delete it. I don't remember the syntax to do that, but you can get rid of it. And I guess what would happen if you, I'm not quite sure what would happen if you kept working on it, if you went back to the experiment branch and kept working on it, maybe what it would show is, sort of stuff meandering off from here that you could then merge back in at a later time. So yeah, I haven't worked with this enough to be able to say, is it helpful to the fact that it didn't get deleted when you did the merge or not? So I'm not totally sure about that. Yes, Dustin.
So merging the branch overwrite the previous files in the master if you have like two of the same file names?
Yeah, it will try and reconcile those. And if it can't reconcile those according to the algorithm that it's using, it will then, and we'll see this in a few minutes, it will then present to you a version of that file with both things in there. It'll say to you, hey, fix it yourself, basically. Question, what was your name?
Ying.
Ying.
Is there a limit on how many branches you can have?
Not that I know of. It's probably many more than we would ever want to use. Okay, so we've been doing all this on this local machine, and yet we obviously know from the fact that I've set up the repository for the class on GitHub that we can do things where we have a remote repository as well as a local copy. So in this particular demo, we could look and see if there is a remote one set up, and it says no, that there's, well, it doesn't say it. It just returns nothing, which indicates that there's not a remote set up. So what I did in order to set this up here was I went to GitHub and it's going to go to, okay. Oops, what's going on here? Email is invalid. It's my email. Oh, this is, okay. Sorry, I want to sign in. I don't want to sign up. Okay. So if I do that. Okay, so this will show my repositories, and I have one called test in here. So basically what I did, I'm going to delete this for the moment. So this is me trying to recreate the process of setting this up. So I'm going to delete this test repository. So now the only repository I have is the class one. And I'm going to now create a new remote repository called test. So I'm going to create that repository. Okay, so I've created it. And now that I've created it, I can basically link my local repository to that remote repository. So we're going to now go back to working in my terminal window. And I'm going to say, okay, add the remote repository, and I'm going to give it a pointer to where on the web that is. And I'm basically going to set up this name that sort of by convention is called origin, that is basically the name for the remote. So I'm going to basically add the remote to be associated with my local repository, and then I'm going to push to what's called origin. That's the name for the remote. I'm going to push the master branch to the far side to the remote, so that we get all the files up there. Okay, so I can go ahead and do that. I need to I'm not sure if that worked or not. Okay, looks like it worked, even though it gave me that error message. I'm not totally sure what happened there. So if we go back to GitHub, we should now see that if we go to there, to test, we should see, oh, that's not good. Huh, okay, so I guess that didn't quite work. The dangers of doing a live demo, I guess. So it seems to think that it knows that it's there, but I don't see it on GitHub. I wonder what's going to happen if I do that. All right, there's something wrong with my authentication with SSH apparently. All right, well I'm not sure I'm going to be able to recover from this on the fly here, so let me just walk through what should have happened, and I will see if I can fix this offline. So this should basically have set up the remote copy of the repository, and then what I should be able to do is go to any other machine or any other place on my current machine and basically clone from the remote repository. So I had been working on Arwen to have when I created that local repository, and then I created the remote, and so then I should be able to clone onto my laptop to get a copy onto my laptop. So that's what I was hoping to demonstrate, where I would basically go to /temp on my laptop and then do the git clone and clone into a directory, say test2 on my laptop. And then what we should have done is seen that all of the files that were in the remote, and similarly all the files that were in the local repository on Arwen, that I was able to copy them over onto the local machine. And I should then be able to add content either on my laptop, or if I wanted to, I could continue to add content on Arwen, and it wouldn't matter where I was adding the content. I could just be doing I could be making the changes, and then wherever I had made the changes, I can do a git push. And what git push will do is basically the workflow is, okay, I'm gonna be in my new local repository. This would be on my laptop. I'm gonna make some change where I create a file. Looks like I forgot to do a git add here, so there should be a git add here and then a git commit. That will then commit the change to my local repository. and then I should be able to do git push, and as long as I have write permission on the remote repository, I should then be able to push the changes up to that remote repository. So treating the remote repository basically as the main one from which I can pull to any local repositories that I like. So this is, I mean, this does work. I haven't, I've been doing this in the process of creating the materials for class, and then you guys have been doing the git clone and the git pull to pull stuff down. And as I make changes mainly on my SCF machine, I've been doing git push to push the stuff up to the repository. So apologies for the glitch there in terms of the demo, but are there questions about any of the syntax or questions about what the sort of workflow of the different steps are? Yeah. Jeff?
Yeah. So when you do the git push, you don't need to specify the remote repository because it already has it linked.
Yeah, so some of these, you could add on extra arguments, but in this case we don't need to, that it's already sort of all set up with the remote, so it should work. Other questions? Yes, and remind me your name?
Elise? Once you push to the remote repository, your code is public. Is that correct?
Right. So yeah. So that's a good point. That you can pay a relatively limited amount of money to GitHub to get a private site on GitHub where you don't have it be publicly available. For the sake of class, I didn't really care if anybody elsewhere in the world decided to download the class material, so I just left it public, and in that case, it's free. And there are other hosting sites other than GitHub. I think there's something called Gitorious and maybe something else, so I don't know what their pay policies are. But yeah, that's a good point. That if you're doing something you don't want to have it accessible to everyone, you want to be careful about that. Yes, and what's your name? Hiron.
Yeah. When you create a repository on your local machine, and do you need to specify that it is a Git repository or any?
Well, we did at the very beginning on Monday. We did git init to create the local repository. So that's basically doing all of the setup. I've already forgotten your name. Sorry, Jimmy.
So like, in terms of Jeff's question, I feel like, if you pull, the system will recognize where you pull all the changes. And if we have like several remotes, do we specify?
I think when you do, as you can see in my hesitation answering, I haven't done this a lot, but I think when you do the git remote add, you're saying it that on the remote side it's this test site. So I think you could have multiple local repositories, multiple remote ones, and I think when you do this git remote add, it's doing the association and the linkage. And so I think when you do the git pull and the git push, as long as you're in the right directory, it'll know where to go and get stuff from.
So it's already connected.
Yeah, and in fact, I mean that definitely should work because I do indeed have multiple repositories, say one from the boot camp, one from this class, and as long as I'm in the right directory and I do git pull and git push, everything works fine. Okay, so let's see if this part of the demo works. So I just want to show you an example of doing conflict management and resolving conflicts. So I'm going to make a new branch that I'm going to call trouble. I'm going to check it out. I'm going to create a new file, experiment.txt. So let me see where I am right now. And okay, there is an experiment.txt. It has some stuff in it. So now I'm going to create a new branch and make some changes to that branch. Okay. And now I'm going to also make some changes to that same file in the master branch. And let's see what happens if I do the git merge now. So this is just recreating what we did before, except now I'm making changes in the same file, and I'm going to see if Git is able to reconcile those changes and merge them together or not. So I tried to do the git merge. It says I'm trying to automatically merge them. Oh, but I found some sort of conflict based on whatever algorithm I'm using to do the merging. It says there's a conflict in this particular file. The automatic merge has failed, so you should go ahead in and fix the conflicts and then commit the result. So let's go ahead and see what that file now looks like, because we know that the issue is in experiment.txt, both because we introduced the issue there, but also because Git told us. And you can see it put a little bit of formatting in here that we're going to have to interpret in terms of what's going on. So this is what was originally in there. There's not a problem with that. Head is indicating a pointer to the current commit on the master branch, on the current branch, because we're in the master branch when we try to do the merge. And it says, okay, in the commit that head is pointing to, we had this text. And then it has these equal signs, and then so it says, oh, this is in the trouble version of this file. And so now this is just text. This is another reason why we would generally want to try to be working with text files when we're working with Git. We can just go in and edit this file to basically resolve the conflict ourselves and decide, do I want both of these lines? Do I want one of the lines? Do I want the other one of the lines? What actually do I want to do here? So the basic idea, and I'm just going to do this with this sed tool that you guys have seen a little bit because I gave you some syntax for sed for the problem set, but I'm just doing this so that I don't have to go in and actually type myself. I'm doing it so I can do it programmatically. So this is me with sed basically resolving the conflict in this experiment.txt file. So now if I look at what experiment.txt looks like, you can see I removed the formatting that Git had introduced. I decided I wanted to keep both lines. This is my new version of the file where I've reconciled the differences, the conflict. And now I can go ahead and commit this. I can check to make sure, am I indeed on the master branch? Yes. So let me go ahead and make this commit now that I made the change, now that I've done that resolution there. And I can do git status, and it says things are fine. And if I do, actually let me do git slog. And you can see now it reflects both of these different branches, both the one we did earlier and this one where I did the trouble branch, and then I had to resolve that and did that merge. Okay, so that is basically what I wanted to go through in terms of Git. Are there any questions about what I just did, or lingering questions from other parts of the material we covered? Yeah, Jeff.
So just trying to understand what's going on in the background of the merge and conflict resolution. When you merge it, even if there's a conflict, it basically does the merge, and you just have to then commit the merge after you resolve the conflict.
Right, you need to resolve it and then commit, right?
Okay, and so Git, when it sees a conflict, actually edits the text in the file.
Right. Okay. If it's a text file.
Right.
I guess if you had created two separate PDFs, I don't know what it would do then. It might make two different names for the file and tell you, hey, you've got two different versions of the file. But yeah.
Correct.
Other questions? Yes. What's your name?
Michelle. Is there a way to, if you have a folder, push or commit the entire contents of that folder?
Well, if you make changes, say in your local repository, you've added a couple files, you've made changes to a few files, and now you do git, and you've committed all those changes. Now you do git push, it's going to make all of those changes in the remote.
Okay, so you have to commit each one individually?
If you do commit, if you had edited a few different files and you did commit -am, it should commit all of those different changes to all of the files. If you're adding files, I don't know if you can do git commit and then star.
It's a period.
Period? Okay. So if you do git commit space period.
Add, rather, git add.
Right, sorry. Right. If you do git add space period, that's what you're saying? Okay. Then that should add all of the files, and that would just be presumably in the current directory. But maybe
It seems to add the subfolders
Did
to
it?
it, but
Okay.
I'm not sure.
Okay, so that would then, sounds like that works in terms of adding multiple files at once. And if you do git status, you should see whether or not it has marked all of those files that you're interested in as being added to the staging area or not. Yes, and your name?
When we
What's
make
your
a
name?
repository,
Wait, what's your name?
Christian.
Christian.
Yeah. When we add a Git repository, we make it remote. It
All the ones that you've committed, yeah.
Okay, and do we have any kind of limit to upload files, like some gig?
Yeah, that you'd have to go and look at GitHub and see what their policies are in terms of what the limits are. Okay. Any other questions? Yeah.
So is there any type of version control system that works on images, not just text files?
I mean, you can certainly use any files that you want in here. And I don't know what would happen, if you have images that are just in, I guess it depends on what the file format of the image is. I don't know the answer to that.
At which level is the Git stuff really working in terms of the operation system? Is that really building into the Unix system so that when I have branches, it's actually, because I cannot really see the directory when it's in the wrong branch.
So all of the, what do you mean you can't see it? I mean, you can.
So for instance, if I'm in the master branch and I did something in the experiment branch, then when I see ls, I don't really see that.
Yeah, you don't see it because basically the differences between the two are recorded in that .git folder where it's basically sort of recording all the differences. So you only see in what's going on in the current branch. Of course, you can check out the other branch and just get over to it very easily.
So where is the other branch in terms of the file system?
Yeah, I don't know all of the gory details of that. My understanding is it's basically all wrapped up in that meta information that's in the .git folder. Basically, sort of what are the differences between this commit and that commit, what are the differences between this branch and that branch? Because often there's going to be incremental differences that are fairly small in size between any two commits or any two branches.
So if I follow around, I do have a chance to mess up all the Git mechanism to really get them synchronized and organized.
I'm not quite sure what you mean.
For instance, if I can go to the folder without we go to the Git stuff and do crazy changes so that it's inconsistent. Then
yeah, I mean, you can certainly make crazy changes. You can always, as long as you haven't committed them, you can always recover. You can always, well, even if you have, you can recover them from a previous commit, and you could check that out. So in principle, the idea is that this provides you the ability to deal with all of those crazy changes that you might have made. Yes.
When I tried the Git remote, I used the backslash instead of the colon, and it works in my machine.
You use the backslash instead of what?
The colon sign.
Oh, here. Oh, yeah, that doesn't look, well, huh. So you did this?
Instead of the colon.
Oh, instead of the colon. Okay, that's interesting. So maybe I got my syntax wrong, and I'd have to check with the PDF where this worked in the PDF of this document. So you can go look at that and see if that matches or not. Okay, great, thanks. Okay, so let's switch over and at least get a quick start on the next unit. So Tessa already started working with R with you guys in terms of being able to read in and output from R. So you've already had exposure to that in addition to whatever you already knew coming in from the boot camp or from your own work. So the basic idea, so the next few units are all going to be about basically programming in R and learning about some various programming concepts by virtue of learning some of these concepts in R. So these units have sort of evolved over the last couple of years, so if I were redoing this, I might combine a few of these units. So it's not quite as, it's a bit more of a mishmash than I would like. But basically this unit 4 has some material on some of the tricky parts of using R and some of the functionality in R. Then in Unit 5, we're going to talk some about debugging and profiling R code and good practices in writing code. And then Unit 6 is more on R in terms of advanced programming and functionality. But in terms of, there's not a hard and fast line between Unit 4 and Unit 6, so just to sort of give you that heads up. Okay, so the first thing I wanted to say is basically from R we can interact with the operating system. So we can do a lot of the things that we've just been doing in the bash shell. We can do them from R. We can query the operating system. So R does allow you to basically interact with the operating system, and that can often be quite helpful. And that's true of other languages as well. Python is particularly good at interacting with the operating system. You can do things from C++ and other languages as well. So it's not like these things are totally distinct. So let's go ahead and switch over. I'm going to try doing the R demos in RStudio and see how that works. So for example, the basic thing I can do from within R to do something at the system level in terms of the operating system and the shell is basically wrap the command I want to execute in quotes and then pass that to the system function, which is a function in R. So if I do that, I'll then see that it just prints out to the screen what the results are of doing that call on the system. Why is that not working? Okay, so it does indeed show that this should reflect what my current working directory is. And this says my working directory is in the bootcamp document, which I guess was the last time I was working with RStudio here. And another nice thing I can do is I can get the results of whatever the call to the operating system was. I can bring them back into R, and that's where this argument intern equals true comes into play. So that's something that's really nice, because I might want to query the operating system, get some information, and then use that information to then change what I do in R. I mean, that might be the main point of working with the operating system in this context. So if I do that, I can say, okay, intern equals true, and now files should be an R object that contains, in this case, it's a character vector that contains the names of the files from doing that ls. So I could then operate on those files, or those file names. And there are a number of other commands built in, things like file.exists, list.files, that basically are specific R functions that will do specific things at the level of the operating system. So you can guess what those things will do from there. And some of these are quite nice in terms of being, when I did system, I then had to enter in this case, a Unix command that would work on my particular Unix machine. That wouldn't have worked on a Windows machine because Windows is not going to recognize what ls means because it's a Unix-specific command. But some of these other specific R functions should be set up to work regardless of what the underlying operating system is and to return back the information based on that underlying operating system. So those are things you can look into if you're needing to interact with the operating system. And then there are some various commands that will basically just sort of give you information about what your system is. So this is saying what my login name is, what kind of machine it is, what the name of the machine currently is, which you can see it's gotten an AirBears name because I'm logged on to AirBears at the moment. And then in terms of internal options within R, if you do options, that will print out a long list, an R list, of different options that are basically how your R session is set up. And you can manipulate these things as well. So if we just in particular looked at the width and the digits arguments, this says basically the width of material that gets printed out on the screen is 77 characters, and the number of decimal digits that are going to get printed out is 7. And if I wanted to change these, I can basically pass the change in to the options function as well. So I could say, for example, options digits equals 3, and now if I create an A and a B, I see it's only printing out 3 decimal places. But if I say, is A the same as B, it says false. So even though I printed it out and showed it to be looking like it's identical, the underlying values are still whatever the underlying values are. So the A and B are not equal in terms of their underlying values. So that's just some basic background information. Another thing that's useful is this session info that will show what packages are currently loaded, this locale information about basically where you're running and what the encoding is that you're running under in the language, and what version of R you're running and what kind of machine you're running on. So all of that can be useful, particularly if you're submitting questions online to a mailing list, it's good to give this kind of information so that somebody knows, oh, you're working on a Mac, you're working on what version of Office, and that's going to help in terms of diagnosing any problems. So let's quit there, and we'll pick up with this unit on Monday, and the problem sets due at the start of class here on Monday.